So today's lesson is about inequalities. And so I just want to start with a quick little brainstorm about inequalities. And so probably the most common symbol you're going to see in inequalities is a symbol like that. Sometimes people call it a crocodile mouth or greater than sign. And so the way it's used is if I have something like, I put a 7 there, if I put an 8 on this side, is that true? Is that statement true or is it false? I want to know in the chat. Tell me, is that true or is that false? What do you guys think? Okay, so it's false. And the reason it's false is that this statement is saying 7 is greater than 8, which is just not true. It's false. But if I change this to 6, is that going to be true or is that going to be false? Yeah, so that's going to be true. Now, I can also reverse this and make it like this. So I've changed the, in fact, let me keep it blue. So I've changed the direction of the greater than sign. Now tell me about this next one. Is this true or is this false? So I'm referring to this one over here. Now, I see a lot of you are saying it's false. Would anybody be able to explain why is this one over here true, but this one over here false? I'd love to know, because it looks quite similar to me. So I was hoping maybe someone can explain to me, maybe if you pop your hand up, if you're willing to share your thinking. But they look, what's different? Pretend I had a momentary amnesia. Yeah, Joy, let's go to you.
Hi, sir.
Hey, can you help me with this? Why is this different?
The first one, it says 7 is greater than 6. And the second one says 6 is greater than 7. So the second one is false.
It's false. And even though it looks
Yes.
similar, the fact that the crocodile mouth is facing the other way is an important difference. Is that what I'm hearing?
Yes.
Cool. Awesome. Thank you so much. Fantastic. Now, there are some other symbols that will come up. And the other type of thing that sometimes happen is this. What happens if I say to you, 7 is less than or equal to 5? Now, in those types of situations, wait, actually, let me not put it that way. Let's put it this way around. Is that true or false? Is 7 greater than or equal to 5? Lock your vote in the chat there. Okay, so this is a little bit sneaky, but this is true because it says 7 is greater than or it's equal to. It's not equal to, but it's an or, so it's fine. 7 is greater than 5, and so that will be true. So sometimes when you see this statement, this extra line here, it sort of doesn't do that much in certain cases, but what about this situation? I'm going to change it now. Is 7 greater than or equal to 7? True or false? Okay. So in this situation, 7 is greater than, no, it's not greater than, but it is equal to 7. And because this is greater than or equal to, this is true. So what this is saying is that if there's an extra line, they can be equal to each other. Okay, so it's important that you sort of get that slight difference. So let me keep sort of going with this, what if I do this? Is 7 less than or equal to 7? True or false? Okay. So this is going to be true because 7 isn't less than 7, but 7 is equal to 7. And so because this is an less than or equal to, the statement is true. I'm having fun with this, and I think we're learning. So let me continue down this way. What about let's talk about this. Is -7, is -7 greater than 6? True or false? And I'd love an answer from someone in the audience to explain what's going on with their answer. How do you know your answer? Who would like to share their thinking about this one? Any ideas? Who would like to tell me how they know, or what they think they know? Okay, let's unmute Annie there, level. Annie, what do you think the answer is? Hi, Annie, can you hear me? Can you hear me, Annie, or are we having some audio problems? Okay, no problem. We can come in later. I see the majority of students are saying this is false, and you're correct, because if you look at the number line, Pomelo is also giving us a nice, love it. You guys are thinking about the right stuff. You can see that 6 is clearly above -7. And so if we wanted this to be true, the crocodile mouth would have to face the other way. Yeah. Okay. These are the basics of inequalities. And then also what we tend to do is we tend to bring number lines into it. Let's just do a quick little vote. Thumbs up if you feel comfortable with the ideas we've discussed so far. Thumbs down if you feel uncomfortable. Wow. Fantastic. Okay, so if we talk about inequalities, we also talk about some other stuff. We talk about inequalities, and then we talk about something called interval notation, so interval on a number line, and also how to represent inequalities on a number line. So that's what we're going to talk about today. So we've started talking about signs. We've got to talk a little bit about interval notation, and then we've also got to talk about representing things on the number line. What I want to point out in this first bit is that if I say to you this sign over here, it is considered open, and the reason it's open is that there's no equal sign next to it. And when we draw it on the number line, we have an open circle and then an arrow pointing upwards because it's greater than. Okay? If we have the next line, greater than or equal to, notice that there's that equal sign next to the greater than. In this situation, we say that the interval is closed. And when we draw it, the closed interval has a solid dot. And then the arrow, because it's greater than, it's pointing upwards on the number line, because things get greater when we go to the right. Then, if we look at less than, then the less than is an open interval, and you'll notice that the arrow is pointing to the left, but we have an open circle. And then if we have less than or equal to, it will be a closed interval pointing to the left, but with a solid line. And so we're going to, in a moment, deal with these types of things, but give me a thumbs up if you've seen some of that stuff before. Give me a thumbs down if you've never seen this type of stuff with inequalities before. we're going to practice it now. It's just to make sure that you're familiar. And if you see me do this, you know that it doesn't include that point. Whereas if I have a colored-in dot, it means it includes that point. Let's go to, I think, is it Laura? Do you have a question, or Laura? Or is that just a vote of confidence? Let me unmute you and see and say hello. Laura, can you? Maybe it might be new and you were just putting your hand up. That's fine. Okay. So let's talk about these three number lines. Now, often when we have inequalities, sometimes they draw them over the number line. Sometimes you have a number line, say, and the inequality gets drawn above it. Or I've also seen in some textbooks, the inequality gets drawn below the number line. It's not really too important as long as you're consistent. In this situation, they've drawn the inequality over the number line. Okay, so that's just to point out. I know some students get confused if their teacher does it one way and we do it differently, but as long as you have a number line and you have some visual indication of what your inequality is doing, that's fine. So what we're going to do in this exercise, we're going to have, this is question 1, 2, 3, 4, 5, 6. I will do the first one. And what we're going to do is we are going to do this in basically inequality notation first. And then what we're going to do is we're going to write this summary in something called interval notation after that. And I'm going to start by doing this with you. So if I look at question 1, I see that my inequality doesn't include 2, but it gets, one of the boundaries is 2. And so what I'm going to do is I want to describe this area up here. And the way I'm going to describe it is I'm going to say x is greater than 2. And what that is saying, notice that I don't have that extra little line here because it's an open circle. So that's called inequality notation. Then interval notation, what it will look like is it will say, okay, on this side, I have a curved bracket and the end point was 2. But because it's not included, it's curved. And then on this side, we're going to have infinity, which is like a sideways 8. And we have a curvy bracket like that. Now I'm going to do another example with you, but in fact, let me do another one. I'll do number 2 as well. So that is what we're going to do for number 1. For number 2, it will be x is greater than or equal to 2. And then the interval notation would be a square bracket because it includes the 2, a semicolon between, and then I have infinity again, and we can't include infinity, so that is a circular bracket. Okay, now what I want is I want everyone to try and write down the answers for 3 and 4 now. So you're going to try and do these by yourself. But for those students who are feeling unsure and want some clarification, I encourage you to ask a question now. Okay, so pop your questions in the chat. If you have any, otherwise, for the rest of us, we're trying to do 3 and 4. You can, and I want you to do it in both inequality and interval notation. Are there any questions out there? Remember to pop your answers in the chat when you have them.
There's a hand from Oratilo, Mr. S.
Yeah, Oratilo, let's go to you.
Good evening, sir.
Hey, how are you?
Oh, thanks, and you.
Very
So
good.
can you just remind me
Yeah.
What the brackets stand for? The
What the
round.
brackets?
Yes,
You
sir.
mean with the interval notation?
Yes, sir.
Okay, so interval notation basically just describes an interval, and if your interval has an end point or a boundary point, like it does in the first one, 2 is that point, a circular bracket says that it doesn't include that end point. A square bracket tells you it does include. So that's why if you look at the number 2 example, it's colored in, it's solid. It has a square bracket, whereas the first one has an open circle, it has a circular bracket.
Okay,
Does that
sir.
make sense? Yeah.
Yes, sir.
So
Thank you very much, sir.
pleasure. 3 and 4 will have square brackets. Sorry, 3 will have square brackets. 4 will have circular brackets. Yeah, let's go to Umta.
Hi, sir. How are you?
What is your question?
Hi, sir.
Hey,
How are you?
very good. Do you have the answer for me?
Yes, I have an
Okay.
answer and a question.
Oh, brilliant. Okay, let's roll. What's your answer?
So I was gonna ask by the third one, is it okay if you said, okay, so X is in the middle, right?
Yeah.
And then like the 2 crocodile mouths are facing the opposite way of each other.
Okay, so I
So-
was thinking they should be like that, right? But I've left something out. What have I left out?
You've left out the line,
Yep.
the lines, sorry.
And now what's going to be on each side?
It's 2 and 6.
Perfect. So X is greater than or equal to 2 and less than or equal to 6. Okay, now, Umta, what about the interval? Do you know how to do the interval notation? What
That
type of
was
bracket?
what I was gonna ask you, sir, because I do not understand.
Okay, so before you don't have to do both normally. You can choose whichever one you like, but I'm showing you both because I just think it's good on the whole. So Umta, can you see that this is a closed interval? The end point is included. So I'm going to have a
Yes,
square
sir.
bracket here, and I'm going to have a 2. What do you think comes after that? What do you think is the next number going to be?
Is it gonna be infinity, sir?
It's not going to be infinity because if
Oh,
you look
thanks.
at the picture, it actually only includes the region between 2
So
and 6.
6.
Yep. Now, is it going to be a square bracket or a curvy bracket? Yeah.
Squared bracket.
Yep. Winning at life. Okay.
Thank you, sir.
Pleasure. Now, I want everyone else to carry on with questions 5 and 6. If anybody is willing to share their answer for 4, I would be very interested to hear it. So pop your hand up if you are willing to share your thinking for number 4. Otherwise, you can carry on with 5 and 6. Yeah, let's go to Luyanda. What would you do for 4, Luyanda?
Hi, sir.
Okay.
So for number 4, I said 2
Yeah.
is less than X,
Okay.
which is less than 6.
Perfect. And then
And for
interval.
the interval, I did the bracket, the normal bracket.
Okay.
2 is G6.
Yep.
And then
Perfect.
yes, sir.
Yep. Absolutely fantastic. Okay, let's do 5 and 6, and then we will move on. I'll give you a minute for those, and then we'll. You guys are looking good though. I like what I'm seeing. Can we do the last one? Vivian, let's go to you. What do you think the answer for number 6 is?
Hello, sir. I'm not here to ask to answer the question. I just wanted to ask one question about number 4.
Perfect.
Can't you? Sorry, sir. Can't you like say that 6 is greater than X and X is greater than 2? or
Okay.
are we reading from left
Good
to right?
question. Very important question you're asking. So I want everyone to listen to my answer because Vivian's asking something which I always see in exams. If you look at number 4, can you see, Vivian, that there's only one region? So because there's only one region, your answer should be basically one thing. So if you had 2 regions on the number line, right? So if you had a bit down here and a bit up here, you could have, x is less than this or x is greater. But the moment you only have one region, this part needs to be knitted together. Does that make sense, Vivian?
Yes, sir. But
Sorted.
sir, I wanted
Yeah.
to ask, how did you know that it was going to be, I don't know how to explain it, but like,
Yeah.
how do you know how do you read it from? Do you read it from
Where
the
I read
2
it from?
all the way to the 6? Yeah,
Okay.
like,
The way I do it for number 4 is I look for the circles and the solid line. So I look at this bit over here. And if I look at that bit, that is the inequality. And it's between 2 and 6, but it's not including the endpoints. So that's why x is in the middle. It's greater than 2, but it's less than 6, but it doesn't include the endpoints. And so that's why it must be together. It can't be like 2 is less than or x is less than 6. You're not wrong, but in some ways, but if there's one region you're describing, you should be writing it like I'm doing like this. You shouldn't be doing it separately like that. Okay.
okay.
Cool.
Yes,
Good
sir.
question though. Very good question. So let's do the last one. So x is greater than 2 and less than or equal to 6. And so this would be 2, and then this 6 would be a solid square bracket thing. Okay, let us move on because I think you guys have done well. If you want to take a screenshot, you can, or come back to the video later. But I think we can squeeze in a little something more before our break. I want to have a multiple choice competition. And I want you to tell me, show which of these 4 options show that x is greater than -1 on a number line. I want you to lock in your vote now. Doom, da, doom, the game show. Doom, da, doom, da. What is your question?
Hi, sir. So my question was about the inequalities that we just worked on or something. How would you know, or how would you know you have to write them like that? Because because we already did this last term. So
Yeah.
we already like wrote exams on it and stuff. How would you know that it's, what do you call this? Like it wouldn't be 2 is greater than x is greater than 2, but x is also also greater than 6. Yeah.
Okay, I'll show you an example where there are 2. I'll show you in this example what it would look like if you had 2 things. Okay, I'll show you now, but let's just answer this question and I'll show you when you would use it to be separated. So, show that x is greater than -1. So x being greater than -1 should be pointing to the right and it shouldn't include, so it should be a colored in circle. So for me, I think the correct option is D. No, I lie. I don't lie. Because if it was D, it would have to have this bit here. It's strictly greater than -1, but it doesn't include -1, in which case the answer has to be B. Okay, so the answer should be B. Now I'm going to answer that question that was asked now before that, but can I just get a quick, if you understood the answer was B, okay, I see a lot of people, can I just ask, if you understand now, have seen me explain it, how I got the answer for B, give me a thumbs up. If you have no idea how I got the answer for B, give me a thumbs down.
Mr. East,
Yeah.
there's a request to please explain it one more time.
Yeah, no, I'm going to explain it now. So, okay. So here's the question that will be asked about how do I know if I want to write this down in inequality notation? This would be x is greater than -1. Now, if I want to have an OR part, the way it would look is, say I had something like this. Then I would have an OR because it's a separate region, and you'd have x is less than or equal to -3, because there's two separate parts. There's the part over here, and there's the part over here. And that's when you would have separate things. But if you have something like this, where that would be x is greater than or equal to 1 and less than or equal to 4, where it's all one thing together. Okay, so that would be when there's two bits of inequality lines, you have two separate answers. When there's one line, you have one sort of group of inequality stuck together. Okay, I hope that helps a little bit with explaining that. Let's do one more question before our break, and we'll keep coming back to this if people are unsure. Okay, which inequality does this number line represent? Okay, lock in your answers here, A, B, C, or D. Well done. So correct answer is going to be x is less than or equal to 2. Because you can see it's going to the left, so it's smaller, but it includes this because it's a colored in dot there. Fantastic, fantastic. Winning, guys, winning, winning, winning. So what I want to do now is I want us all to stand up and I want us to take a break because we worked hard and we want our brains to click save as so that this goes into our long-term memory. At least I hope it does. And I want you to turn on your cameras and I want you to stand up with me and to just swing your arms and take 5 nice deep breaths.
Please turn on your cameras, guys. Let's see your lovely faces.
One more. Yeah. Now, what I want you to do is I want you to roll your shoulders, to do 5 rolls back. 1, 2, 3, and look out in front of you 4, 5, and then look forward. 5 rolls forward. 1, 2, 3, 4, 5. Okay, shake your arms out. And I want you to twist a little bit, a slow rotation from side to side initially. And then with time, I want you to slowly let your hips go further. And then by the end, hopefully you're getting almost to 100. You kind of get all the way around almost. Oh, click. Okay, then let us do a quick shoulder stretch. 1, 2, 3, 4, 5. Other side. 1, 2, 3, 4, 5. Okay, and then I want us to grab a pen nearby. So go and grab a pen of some sort, a pen or a marker if you've got one. And what I want you to do is I want you to hold it on the one end, and I want to see if you can throw it in the air and catch it where it spins only once. So basically, in fact, let me go full screen so you can see me. Okay, so basically you have a pen and you're holding it and you want to throw it so that it spins once and you catch it on the same end, but it must only spin once. There we go. So you throw it and you catch it. And it must rotate only once and you catch it the same end you did it. It's called pen flipping.
Vivian seems to be doing well.
Oh, it's hard.
Yeah.
Okay, one.
Oh no, it's all about to drop it. Oh no, it's okay, girl.
So your natural inclination is to make it spin lots, but to make it spin only once and catch it is hard. Ah. And so it forces your brain to really focus. Oh, I can see I'm rusty. I haven't done this in a while. I used to be ninja levels. Okay.
Oratile looks
So-
very dedicated.
Yeah, and one more thing, our heart rate's up because our bodies now are a bit more relaxed, but we need to get our blood pumping. And you know what we're going to do? We're going to do some jumping jacks. So make sure you're clear. And we're going to start now. 3, 2, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All done. Have a seat.
So proud of you guys for doing it standing.
Well done. Tell me in the chat, did that actually get your heart rate up? So I want to know, did you feel your heart rate rise a bit from that exercise? I want to know, or are you like, listen, old man, that doesn't get my heart rate up. All right. Okay, I'm glad. So we had such a big workout today. I am going to skip the math 24 for today, but we did some pen flipping. And pen flipping is hard, like, trust me. And you can even make it harder by using your non-dominant hand. But I'm glad you enjoyed the exercise. Okay, let's go back to this stuff. I want you to tell me which of these 4 options do you think is the correct answer? So it's got one end where 4 is included, but 1 is excluded. So it can't be this one. It can't be that one. And because 4 has to be included, the answer should be D. Okay. So you guys are really getting good at this. So I promise I will get it. Okay, let's do this one. Which of the following best describes 6p less than 12? What is the correct word to describe? Which of the following words best describes 6p less than 12? Yeah. So obviously we're doing the topic inequalities, so this is an inequality. Now, we haven't done this so far, but I'm going to solve this inequality because at the moment, I don't know what the answer is. When we solve an inequality, we ask ourselves, we want to get the p by itself, essentially. We want to get the variable by itself. And so inequalities behave a lot like equations, except for 1 or 2 differences. In this situation, because there's a 6 here, I'd really like the 6 to go to the other side. Or I could say I divide both sides by 6. If I divide both sides by 6, I get p is less than 2. And so that is called solving an inequality. If you want to illustrate this answer on a number line, you need the point 2. And because it's less than, and it's not included, I'm drawing it below the line here. That's what the answer to that inequality would look like. So there's a little bit of algebra, and then this is called, this bit here is called the graphical solution, or showing the solution. So basically, all the numbers are less than 2 are included in this inequality. So if I chose the number 1, for example, does 1 make the statement true? Well, let's check. 6 times 1. So is 6 less than 12? True or false? What do you guys think? Is 6 less than 12? Yeah, it's true, right? So when I put the number 1, it worked because it was less than 2. But what if I choose a number like this? Let's say I choose number 3. If I go into this expression and I go 6 times 3, that would be 18. Is 18 less than 12? True or false? No. Okay. So, and that's what I was just trying to show you, that in this situation, this is showing you all the numbers that would make the statement true. And as long as the number is less than 2, it makes the statement true. Let's go to Shanique. Let's go to you.
Hi, sir.
Hey, how are you?
I'm good. So I want to ask, when you divide, doesn't the sign change?
Oh, good question. Okay. In inequalities, if you divide by a normal number, the sign does not switch around. But if you divide by a negative number, it does switch direction. Okay, so
Okay.
a little bit more about this, maybe end of today or at the beginning of the next lesson. But if you divide by a negative, the inequality sign does have to switch around. I'll give you a little example of this. So I think all of us would agree that 3 is less than 4. Right? Would everyone be happy with that? I think so. 3 is less than 4. Let's now say that we divide both of these by -1. If you divide 3 by -1, you would get -3. If you divide 4 by -1, you get -4. I want to know, is -3 less than -4? True or false? Think about it for a little bit. Is -3 less than -4? So if I think of the number line, maybe here's 0, here's -3, here's -4. I think -3 is actually greater than -4. And so what's happened is, because I divided both sides by -1, what I should have done is I should have switched this to go the other way around. But that will only happen if I divide or multiply by a negative. Now, I will do this up in the next lesson as well, but it was a good question, so I thought I'd make a little bit of extra effort to illustrate this. Give me a thumbs up if you understand what I mean. Like the fact that when I divide by a negative or times by a negative, I have to switch the lines around. But when I divide by a normal number, I don't switch anything around. Okay. Awesome, awesome, awesome. Okay, well, let's go on to solving the inequality. So I'm going to do an example one, and then you guys are going to do one after this. So if the question says solve this inequality, all I need to do is sort of think of it like an equation, except that an equation will either have 1 or 2 or 3 answers, whatever the type of equation you have. Whereas an inequality, it can have many answers. And so in order to show those many answers, we often need a graphical way of showing the solution, or some sort of graphic that shows our many answers. So let's see what it would look like. If I start with this and I add 1 to both sides, I would then get 2x is less than 10. Now, if I divide both sides by 2, now remember there's no switching around because I'm just getting rid of this, I should get x is less than 5. And if I want to show this answer on a number line, I need a 5, I need an open circle, and I need a line that goes like that. And so all answers to this inequality, things that will make it true, will be less than 5. So 4.5, 3, minus 10, those will all make the inequality true. If I choose the number 12, which is bigger than 5, let's see what happens. 2 times 12 is 24. 24 minus 1 is 23. Is 23 less than 9? No. So I'm just kind of showing you that this does tell you something useful. Okay, so using this idea, I want you to try and solve this inequality, and then I'm going to go to Umta to answer her question now. Umta, what is your question?
Sir, I was gonna ask you if the question or whatever the statements doesn't have that thing, if it's less than or equal to the line, right? Your answer is not gonna have a line.
Yeah, exactly. So this thing at the beginning is this thing at the beginning is
Thank
what
you,
will
sir.
be. Yeah. So let's do this one and let's see how it goes, and then someone can tell me the answer. And if you're feeling very on form, so I'll call this number 1. I'll call this number 2. Okay. So for number 1, the answer should be x is greater than 8. And if you illustrated it on the number line, it would look like that. Yeah. And so I added 8 in step 1. So I added 8 to both sides, and then I divided both sides by 3 to get that. And then my last step was just to draw the number line, and I should actually have arrows on my number line, to be fair. Now, one more question for today, or maybe 2 more, we'll see how time goes. This is more of a wordy question. So n is an integer. Now, an integer is a number without a fraction. So the integers are like -1, -2, 0, 1, 2, 3, 4, and such. And they're saying in this situation, write down all integers that are greater than -2 and less than or equal to 3. I want to see, can you write down which possible values, what integers exist between -2 and 3? See if you can write them down for me. Good question. So Annie's asked for question 1. Why isn't the representation for 8 a closed circle? So Annie, if you look at this, it's greater than 8. If it was greater than or equal to, then you would have a colored in thing here. But because it's not, because that extra line here, it doesn't include 8. And so that's why you have an open circle. Who would like to come online and give me the answers for number 2? Who would like to give me the answers for number 2? Who's feeling like it's their time to shine here, or to share their thinking? Yeah, Oratiwe, let's go to you. What do you think the answers are for number 2?
So I think the numbers are any numbers between from -1 going up to +2.
Okay, I agree with you to that point, but I think there's a little bit of extra that sneaks in there. So I agree with you, it's -1, 0, 1, 2, but I think we add 3. Why do you think I'm going to include
Oh yeah,
3?
so because of our sign, it has a line underneath, so that you
Yes. So that was sneaky, but can you see this is less than or equal to? And so because of that, 3 gets in the team as well.
yes, sir.
Yeah. You did fantastically well, though. Thank you, Oratiwe. Okay, guys, you are doing well. I want to find something that's a bit more exciting for you to finish off. So I feel like you earned it. Okay, let's end with this one, because you've earned it. Solve the inequality 2 times 3x minus 5 greater than or equal to 43. Solve that inequality. Think back to your algebra steps. What do you need to do when you solve an equation, and how could you modify that to help you? And there's 2 ways to do this. If I could ask the class, what do you think our first step should be? There's probably 2 ways, 2 first steps, but I'm interested to know what most of you are doing as your first step. Yeah, I think I would multiply 2. Yeah. Not everyone will do that, and that's fine, but I think life becomes a lot easier if you do that. Yeah, I agree. Oyisa, I agree. So what's my answer going to be then? If I add 10 to both sides, I think I'm going to get 53. And notice how this stays the same throughout. And now my last step, you could maybe use your calculator, or you could just go 53 over 6. And if you want, I'm guessing 48, so would be, you could also write it as a mixed number if you like. Basically, x is greater than 8 and 5 over 6. If I wanted to illustrate this on a number line, I'm just going to write 53 over 6, and it's greater than or equal to. So it's a colored dot, and it's going to be all those numbers that are greater. Okay. If you type in your calculator, it looks like you will get somewhere around 8,83. Level, if I could ask you to put the link to the feedback poll, and then I'm going to take the question by Tesco while we do this. Tesco, what's your question? Can you hear me?
Can you
Hi.
explain it? Hello.
Again. Yeah.
How are you, sir?
Hey, how can I help you?
I don't understand. Can you explain me? I can't.
Okay, so did you understand the multiplying out, Tesco?
Yes.
Okay, so you're okay with that. Are you okay with adding 10 to both sides? When I add 10 here and I add 10 there. Does that make sense to you? Okay, we seem to be losing Tesco, but I'll go through it again. So I'm adding 10 to both sides, and that's why I get this goes away, but this part gives me 53. And then what
Yes.
I'm going to do is I divide both sides by 6, which means that that goes away, and x is greater than or equal to 53 over 6. 53 over 6 is an improper fraction. So if you go on your calculator and you check how often does 6 go into 53, you'll see that it actually goes in 8 times, but then you've got 5 left over. And so you can convert it to a mixed number, or if you use your calculator, so in fact, I'll just get that quickly. So what is 53 divided by 6? You get 8, so you get 8.83 if you round off to 2 decimal places. Okay.
Yes.
So I hope that was helpful, Tesco. Did that help you?
Yes, it helped me. Thank you, sir.
Pleasure, pleasure, pleasure. All right, everyone. I hope you enjoyed today's lesson. You did nicely. In the next lesson, we will look at some more difficult inequalities, and we will also talk about something called a quadratic inequality. And a quadratic inequality is just basically when you have an x to the power of 2 in your inequality. And we'll have a few more ones with brackets and a few more ones with maybe some fractions, but really you've understood the main ideas behind inequalities. It's just doing more examples of more difficulty that we'll do going forward. Okay. And if you could please give us feedback, if you can please give us feedback in the chat, we really appreciate your honest feedback. I'm just reading the chat here. So can you go back to our previous examples and explain how to know in a number line that where is the sign supposed to look like and how? Yeah, no, we're going to carry on. Okay, Bernardo's asked, didn't you say integers are not fractions? Because I'm a little confused. In that question, they specifically said integers. If they don't say integers, so let's go back to that question over here. When they said that was a special case, they said it is an integer. However, if they don't say that, then it includes all numbers on the number line. Okay, so I hope that helps a little bit. Cool. Pleasure, Samila. I'm glad you enjoyed it.